Hey everyone, in this video I'm going to go over some example problems applying the ideal gas law. So here's the first example. I've got my ideal gas law equation and the two R values we discussed in the previous video at the bottom of the screen. Let's read and label the numbers we see as we go. A 1.55 mole sample, okay, so there's moles, that's my lowercase n, of an ideal gas has a pressure of 250 kPa. So that's going to be P. It is held in a 12-liter container. So liters, of course, is volume. What it's asking me to solve for here is the temperature, so T. So I went ahead and plugged in all of these numbers, 250 kPa, 12 liters, and 1.55 moles. Now, with the ideal gas law, it's extra important to check your units to make sure that the units are acceptable. So my pressure, I've got kPa, that is an option. My volume is supposed to be in liters, that works. Moles, of course, is going to be in moles. So all the units line up. The next thing I'm faced with is choosing an R value. Now remember, you can use either one, but we need the units to match. And it all comes down to my pressure here being in kPa. So you want to make sure to use the R value just to make life easy on you that already has kPa. So we're going to plug in the 8.314 R value. So here's my final equation. The only thing left is the algebra to solve for T temperature. I'm going to keep doing this all in one step and divide both sides by the 1.55 and the 8.314. Dividing both sides by those numbers will cancel them off here and here, leaving me with just T on one side of the equation, which is the entire point. Now all we have to do is plug in those numbers to my calculator and solve. If you do the math properly and then round off to a reasonable number, we get 233. Of course, we have to give that units, so I go back to my R value one last time, which tells me the units that everything has to have. This answer is in Kelvin. And the question didn't ask for in any other temperature unit, so I can just leave the final answer as 233 Kelvin. Here's a second example talking about 3.1 moles of a gas, so there's my N, at a pressure of 8.2 atmospheres, so there's my P, and a temperature of 20 degrees. This time we're solving for the V volume. So here I've already filled out the P, V, and N into the equation, left blank the R and the T. We've got a decision to make with the R value. Which should I choose? You can choose either one, but let's make life easy. My pressure now is in ATMs. So to make the pressures match, I want to use the R value that also has ATMs. So in this case, we're going to be using the 0.082 R value. And you can see I just kind of left off the 0.5 just for space, but we'll use those numbers when we actually calculate the answer. The last issue here is temperature. They gave me a temperature as 20, but it's in degrees Celsius, and my R value units tell me that the temperature has to be in Kelvin. So the equation again is take that Celsius, add 273, so the temperature that I've got to use is 293 Kelvin. Now all we have to do, of course, is the algebra. Dividing both sides by 8.2 should cancel it off and leave me with V equals whatever the answer is. So after we multiply 3.1.082, 293, divide by 8.2, we get a final answer of 9.1. Again, we need units on this. Go to my R value just to double check. It tells me that the volume will have units of liters. So my final answer is 9.1 liters. And we'll end with one final extra challenging example. We have to pay attention to a lot of details in this. A 10-liter gas canister, so there's my volume. Right away I see 50 grams, which confuses me because nowhere in PV equals nRT can I plug in grams. So I'm not sure what to do with that yet. Let's label it as a question mark. I do get a pressure of 25 psi, and I do know that I'm solving for the temperature T. So I went ahead and plugged in what I know, leaving blank the N and the R, because right now I'm not sure what to do with those. Let's start off and figure out what to do with this N. Now it doesn't tell me moles, but the problem does tell me grams. So if we think back to something we studied earlier in chemistry, you might remember that if you were given grams and if you had a periodic table, which of course we can always look up, you could convert grams into moles by finding your elements. So this question is talking about XeF4, so there's Xe and there's F. And looking up the molar masses of these two elements, there's xenons and there's fluorines. And if you add up the molar mass of the gas, in this case XeF4, we can use that molar mass to convert those grams into moles. Here's how it works. So I'll start with the 50 grams of XeF4 gas, and I want to cancel off and change those grams into moles. So just like always, we do this with dimensional analysis. Grams is on top, so grams has to be on bottom. To change those grams into moles, it's just one conversion step where the certain number of grams are equal to 1 mole of that gas, and the number 1 always goes with moles. That's how molar mass will work. The only thing you have to look up is how many grams is equal to that 1 mole, and that's what we need my periodic table for. So 1 xenon with its molar mass and 4 fluorines with their molar masses all combined give me a molar mass of XeF4 of 207. And I'm rounding off a little bit there just to keep it simple. Let's actually keep in the decimal we're supposed to so we get a nice accurate answer, 207.3. So now I can divide and find out that those 50 grams of xenon gas is also 0.2412. I'm going to leave in a bunch of decimals, and that is how many moles there are. So now that my amount of gas has been converted into moles, I can plug it in for lowercase n. So now that n is figured out, I can move on to my R value. There's 2 of them to choose from. I can pick whichever I want based on the pressure units of atmospheres or kPa. Now the problem with this question is that the pressure unit that I was given is neither. It's PSI. So that means I can't use the 25 PSI that I was given. I have to change this to match whatever R value I choose. So you can literally choose whichever R value you like. My preference is usually the 0.082 option. I'm not sure why. Since I'm choosing this R value, then the pressure I plug in has to have ATMs. So I've got to do another side conversion and convert PSI into atmospheres so it matches my R. So here you can see the conversion factors between all the pressure units. Using that to change 25 PSI into ATMs, my conversion looks like this. To get a pressure of 1.7, now I can plug that in here since it's been changed to atmospheres. And I've got that written out in green just so we can help keep track. Now all the numbers are plugged in the proper units. I can end by simply doing the algebra and solving for T. Dividing both sides by 0.2412 and 0.082 leaves me with a final temperature equal to 859 Kelvin as my temperature. Now this problem has one last little trick to throw in. It asked for temperature, but it asked for it in Celsius. So you technically would not leave it in 859 Kelvin. You'd finish it by subtracting out the 273 to get the answer in the proper units. This comes out to 586, and now in degrees Celsius, so now can be my final answer. And that concludes this video. Thanks for watching.